Well, hello students. This is going to be a run through the calculus NCEA or NZQA Level-2 2021 paper. What I do with all of these is I do them pretty slowly, so let's have a look as if I'm sitting the exam, just to show you that it's not always that easy, even for an experienced tutor. Now, they give any times for these? I think you're sort of supposed to do maybe 1 hour on each of these. This video also, I may make it public later just to show people that I mean, I'm not a genius, but I'm very experienced, and even for someone like me, you know, I do sort of low level but quantum gravity research, stuff like that, macroeconomics modeling. And even for someone like me, these exams can take a while to do, especially if you make a mistake and you catch your mistake and you sort of want to go back and fix it. You sort of can't resist the urge. You can spend a lot of time on these exams, and so my message to the NZQA is to give students as much time as they need. Basically, you know, you can do exams on the same day. No one's going to go out of class and then come back and cheat if no one has any electronic devices on them. So it can be a problem if you do at-home tests during a lockdown, but in that case the examination papers should be completely different to fit the needs. Anyway, here we'll start on this. It's all sort of real time. I haven't looked at these papers before, and so you'll see what it's like even for an experienced mathematician. I'm a mathematical physicist, but same thing when it comes to NCEA, more or less. One thing is I don't teach day to day this stuff, so it is very much like I'm just a very good student, not a genius or anything like that. Certainly not a teacher. Teachers tend to get in the habit of solving these problems, and so they can do it a lot quicker. So if you start timing from, say, now, you'll get an idea of how long these exams can go for, even for a good thinking person. All right, I want to know the gradient of the graph. So the gradient is df by dx, or if you like, f prime of x. And so let's firstly write down the general form for the gradient. So it'll be 12x squared minus 4x plus minus 7. And then at x equals 3, it'll be 12 times 9 minus 12 minus 7, which is basically 8 times 12. Is that 96 minus 7 equals 89, right? But of course, rather than doing it in my head, I'll pull out my calculator. For my students, my tutorials, I use Python just as a desktop calculator, but so the formula entry will be a bit different for you with your Casio or whatever FX calculators. But if you got time in the exam, you should always check your working as a gradient. Sometimes I'm a bit paranoid about how they mark these exams, and so I might explicitly say what the answer is. Sometimes I'll do that. Sometimes I'll leave that for you to do, and I won't bother, but probably it's a good thing in the exam to explicitly state what your final answer is, some way or another. So the tangent to the curve will be a line y equals ax plus b, slope and an intercept. So if it's a cubic, it's probably, I don't know, something like that. And say x equals 2 was here, it's the x-axis there, then the tangent line would be this line here. Okay, so we've got to find the slope, and 1 point on the line is the way to go for this. So first of all, the slope of the tangent line slope A equals the derivative at the point of tangency, x equals 2. So that'll be 3 halves x squared plus a half evaluated at x equals 2. That's how you sort of do an evaluation symbol at the end, vertical line. So that's going to be 3 times 4 over 2 plus a half. So it's 6.5. Okay, and then to find the intercept, we just take the point on the curve at x equals 2 is the only point that we know is on the line, and so so y at x equals 2 will be the same as the value of the function at x equals 2 itself, because that's where the tangent intersects the function. So that'll be 2 cubed is 8 over 2 plus a half times 2, which is just 1, so it'll be 5, and so we can plug that in to the equation for the tangent line to say that 5 equals a, the slope, which was 6.5, times x, which at this point is 2, plus b, and that implies the b would be equal to 5 minus 6.5 times 2, what's that, 13, right? So it'll be -8. So the tangent line is 6.5 x minus 8. Now I'm actually already nervous, even though this is not an exam. I can actually generate nervousness just by doing a fake exam. I'm kind of trying to rush things a little bit here. Maybe I should slow down to make it to show the examiners at NCEA that it really should be less stressful. And if it's less stressful, it's going to take you a lot longer. Number of daily viewers on a video game. See, now I'm kind of thinking, oh, what the heck's these curly things? There's a lot of stress involved. Anyway, basically we've got another quadratic. Find the rate of change of the viewers with respect to time when the number of daily viewers is this much. Well, v is the number of daily viewers. So we want v prime, which is, dv by dt. So that'll be minus 22t plus 528, valid for times less than 48 hours. Sorry, months. 48 months. Right, so now we need to know the time. So we need to find the time when v, not the derivative, but v itself is equal to 3,520. So it's a pain. You might want to take your calculator out and solve this. So it'll be minus 11t squared plus 528t. And if we stick the v on the other side of the equation, then it'll be negative 3,520 equals 0. So you've got your a, your b, and your c for the quadratic formula. And so we'll get two solutions. Square root 528 squared minus 4 times negative 11 for AC. C is negative 3,520. If you don't like all the negative signs, you're going to swap them all around. Multiply the whole thing by -1 if you like. And then I can't draw these horizontal lines, although that one was pretty good. So sometimes I'll just put a big bracket around and divide by the denominator, which is 2a negative 22. So again, I'm not sure how you would do it in your pocket calculator, but sorry, my window just resized there randomly. So So I'll do a big bracket first of all and do the divide by 22 if I've got a formula entry calculator. And then I'll do the plus square root first. And then I'll do 528. Now Python squaring is 2 asterisks, not a caret symbol. It'll probably be a caret symbol on your calculator. Now I've got 3 negatives there, so I can just merge them all into one negative. And then I've just got the multiplication. I can remove the brackets. Okay, 8. So it looks like we could have factorized it nicely if we bothered to do a factorization. 8 or 40. Well, 40 isn't beyond the time. So you start to wonder now, already there's a lot of anxiety because it doesn't pick out a particular solution, because 8 and 40 are definitely in between here. So if you were doing this, you might just double check that. One of them might be wrong. So try t equals 8 and then do the calculation. Plus 528 times t. So that works out alright. And probably it looks like 40 is going to be correct, right? So anyway, let's do the rate of change function. So it'll be minus 22 times t plus 528, and if I do 40, it's negative. So yeah, it goes down and up. So what we've got is the v goes like this, and so at 8, oh hang on, must go the other way around, right? Because it's a concave parabola, right? So it goes like this, and over here somewhere it's the slope is 3,520 at t equals 8, and over here at t equals 40 the slope is negative. So this is a positive. So t equals 8 has the positive slope. Plus 3,520. Therefore the oh no, that was 3,520. Yeah, so what, hang on, what was the slope? 352. Well, okay, so 352. I was getting confused between the slope and the function. The value of the function is 3,520, but the slope is 352. So it doesn't say that it's a positive rate of change. So I don't know. So the rate of change would be equal to 352 or negative 352, depending on the time. I'd hedge my bets and leave it like that. Both because 40 is within the range. So yeah, there's the maximum number of daily views that this new presenter gets during the first 48 months. Okay, so the algebra way of doing this in level 1, you might remember, and this is a good check, is to use the symmetry of the parabola like this. So we've got 8 and 40, and so halfway between them is 48 divided by 2, 24. So we could just plug in v of 24. Okay, I had the formula right before, so I could just put in 24 here. So 6336. Could be my answer, right? But using calculus, so that's method A, method B. Set the derivative equal to 0 to get a maximum. Since it's not a cubic function, there's not a double maximum or anything, or a maximum minimum, so we only have to worry about one. Note that it's concave. That tells the examiner we understand there's only one solution. Okay, so the derivative was, wrote it down up above there, 22t minus 22t plus 528. So that means, so, well, it should come out to what we had before at 528 divided by 22. Voila, nice. Okay, 22 months. And then at this time, the will be equal to, plug that in, the number of daily views, not the rate of change this time, so it'd be minus 11 times 24 squared. What is it? Plus 528 times 24. And I'm going to say, well, it feels like cheating to do this. But anyway, oh yeah, so I already did that, right? 6336, yeah, right. So what am I doing? I need to do it again. This is max. What happens after the first 48 months is anyone's guess. Right here, I'm thinking this is too easy, so I'm thinking there's a trick, and I've missed it. I've missed the language trick or something. Maximum number of daily viewers, first 20 hours, new presenter on a video game. Yeah, I can't see any tricks, so maybe it is pretty simple. In a calculus exam, I'd only use this algebra method as a double check. I wouldn't. I'd kind of dive straight into calculus and not waste time with the algebraic method using the symmetry of the parabola. Probably that's what I'd do. Okay. Another different function, which is a positive cubic, so it goes down from the right, up and down like that. Use calculus to determine if the string after it ever stops earning money for the presenter. Does it ever stop? Will it ever go to? Okay, well, it's a little bit tricky. So t is greater than 0. So we've already got a cutoff here. It starts at the so the y-intercept is 0. Well, that makes sense, I guess. And then it's so below that it's going to go down to negative infinity because it's a cubic, right? But then there's a possibility that there's a couple of possibilities, right, for this. One is it's already gone down. It's already hit the minimum. The other possibility is it hasn't hit the minimum, and it might go like that. And another possibility is that it might go like that. So really what we want to do is locate the minimum, because that will tell us whether it's ever going below 10,000 after t equals 0. If the minimum is like this one at a negative time, then obviously the answer is it will never stop earning money. So we don't know what happens here. So let's find the minimum. Find the global minimum. So we're going to set v prime equals 0, which means 0 is going to be equal to the derivative 3 times 1.6, right? Don't trust myself. 4.8 sounds about right. T squared. Sort of do a bit of cheating here and move the stuff up here. Get it out of the way. I'd always keep a scrapbook in the exam on the side of my desk, so that I can scribble these things, these doodles down. Wasting time here. Minus 260 t plus 2900. All right, so we've got to solve this. So we'll get a solution. Squared minus 4 times 4.8 minus 2900 divided by 2a. 4.8 times 2. What the heck's that? 96 or something? 9.6 I mean. Yeah. Now put that in. I know you guys have a function on your calculator for entering in these polynomials and solving them, but I do too in my software, but I'll just show you the sort of long way to do it. So those are all negatives, so 4 times 4.8 times 2900. Now I could have easily written 2000 because I was untidy, and so I do recommend you maybe don't rush your handwriting in your exams, because when you're on autopilot it's easy to make those kind of little short-term memory glitches. 38.45 was positive square root, and 15.7, 38.5. Again, both of them are within the allowed range, but it's a qubit that looks like this, not the other way around. So the minimum is the one at the greater time, but it's that shape. I don't know whether to call it convex or concave. So therefore the t at the minimum is going to be the right hand side, the higher time, 2.5 months. That's t minus, that's t plus. T plus is at the minimum, t minus is at the local maximum. Right, well that's a positive time, so it was and the minimum was at positive time, so it was this particular case here was the one that we've got. So v minimum is going to be equal to 1.6 times 38.5 cubed minus 130 38.5 squared plus 2900 times 38.5. All right. I'm probably only going to do this once, but let's squared I should have put the time in there. 10,264. Right, so, but of course it starts at 0, so what does it mean? If the stream falls below, once the stream reaches 10,000, so that's somewhere before this, because it starts at 0 here, B, and so it's definitely going to at some stage go to 10,000 before it goes to the minimum. So in fact it kind of looks like this, right? Starts at 0. Minimum is, say it's 1 2 3 4 5 6 7 8 9 10. Well, actually, stuff that. Let's just say 5,000, 10,000, 15,000, 20,000, whatever. You know, it's going to go up, and then at 15.7, it'll hit the maximum at 38.5. So I don't know what the maximum is, but it's going to go up there, hit the maximum, come down, hit 10,000, 10K here somewhere, and then shoot back up, down below, it's like that. Okay, anyway, we solved it. So it should never stop. So by this model, it will not get demonetized. Of course, the model could change anytime, depending on fashion. Okay, graph 2, nut question 2. All right, let's have a look at this one. Sketchy problem. Don't like these at all. So first thing is to figure out whether we're given f prime, we have to sketch f. That's the hard problem. If we're given f and we have to sketch f prime, that's probably the easier one. So it kind of gives you an idea of what how much effort to put into these. This is the easy one, relatively. So the gradient is 0 at these points here, so let's count them 1 2 3 4 5 6. Hopefully it kind of lines up, right? 1 2 3 4 5 6. So the gradient is going to hit 0 there. Looks like it's 0 at x equals 0, and 1 2 3 4 5 6. 1 2 3 4 5 6 goes there. Okay, what else can we say? Might want to put a scale on this. What I would do is I'd go 1 2 3 4 5, and I'd only bother with 1 and -2. Okay, 2 4. Just do a couple of them. We don't know the scale on the x-axis, so that's irrelevant. All we know are these ones. So I want to know when the slope is around about 45 degrees in whatever units we've got. That means the derivative is equal to 1, or plus or minus 1, say 45 degrees. So that way plus, this way minus. Okay, so when is it equal to roughly 45? I would say it's actually hard to say. Yeah, it doesn't actually matter if this is like 1 2, because it's gonna scale itself kind of. So 45 degrees is 45 degrees on the graph paper, and that looks about here, right? So if I draw a line, well, if I just draw a line sort of 1 to 1 here, so I've got a 1 and a 1, I think. Yeah, so 1 to 1 on this is actually not 45 degrees. Let's just say it's like that. I can actually draw it. I can draw a straight line. let's say 1 to 1 is from there to there, right? So that's our nominal 45 degrees. So that would be, sort of line it up there. It'd be about x equals -2 on the scale that I've drawn it. So it'll be when it's +1. And by symmetry, this looks like sorry. This looks like it's proportional to x to the 4, right? So it'll be symmetric, plus and minus x. So on the other side, at 2, it'll be also there. Okay, and then what else can we do? I guess I could move this. Well, let's do it exactly. Let's kind of sort of tend to do it exactly. By the same reasoning, that should be my one gradient of 1 in the negative direction should be like that. So, whoops, somewhere there. And well, we'll just use symmetry. Where else could it be +1, right? It could be somewhere here. That'll be the symmetric thing, and also, of course, over here somewhere. Okay, so we'll try to match those up. That's about that's 1 unit away from the minimum there. That's going to be a negative slope. -1, say, around about there. And then +1 is like 1.5 to the right here. And then sort of a maximum slope is around about here. Max slope. We don't really know what that is. We could roughly guess it. It's about 2. It's about 2 or something. Around about +2 slope. And then it goes down to 0 here smoothly, so it sort of goes like that. And then we could just do the symmetry lines. So 1, 2, 3 be about the maximum, and then oh, sorry, symmetry. Symmetry. It's a negative. It doesn't go down like that. It goes, yeah, because it's roughly a point of inflection there, kind of thing. So it's going to go down. About there, and then +1 again at about 1 to the right of that. +2 is sort of roughly a little bit longer, a little bit further along, and then a minimum slope is around about here. Or the most negative, the steepest negative. That's about 1, 2, 3.5. So 1, 2, 3.5, and that's about, I don't know, -2 slope or something, roughly like that. Now this looks a bit straight. Yeah, it's a bit dodgy, right? Maybe this point's further down, and maybe this point's a little bit further up. Maybe this point's further down. I don't know. So I basically would sort of sketch it something like this. Maybe miss that point. So it's not an exact calculation at that point. Okay, something like that. Both sets of axes is the same horizontal scale. Well, that's kind of supposed to be your 45-degree line suggestion. So you could do something like that. I would say you know, I would say maybe do a better estimate of the maximum and minimum slopes there. The other points that we've got for sure are these points here. And what else could you do? You could do a more accurate estimate of where the 45-degree slope is on each side, right? Those would be these points here, here. We are at slope of either +1 or slope of -1. So, but I'm not going to waste time with that in an exam for sure. On the side, I would write something here. Write about the maximum plus or minus slopes and the 45-degree plus or minus slope, plus or minus 1 slope points. Just write something about that, roughly where they are. Do a rough calculation. If I want to find this unknown quantity here, and we're going to have some equation to solve for it. A point on the graph where the gradient is -5. Okay, well, first of all, maybe you find the formula for the gradient. 3 plus 2c x minus 6x squared. That equals -5. No, it doesn't. Therefore, 3 plus 2c times 2 minus 6 times 2 squared equals -5. So therefore we've got 4c equals -5 minus 3 plus 6 fours 24, right? Well, that should be right, 16, right? And so therefore c equals 16 over 4. Okay. Quick cup of tea here. It'd be awesome if you could have a cup of tea in an exam. Okay. In a future civilized society, we will have cup of teas in exams, or at least water. The acceleration is constant. Oh, trying to be physicists, are we? Well, physicists did invent the calculus. Velocity. Well, we have to know a bit of physics here. Yeah, so initial velocity, so time equals 0, right? Equals 2.8. And the acceleration equals the rate of change of velocity if we're in a straight line, and that's a vector. But we can decompose vector components, so we can do it vertical components. And then, so this is the y component. Yeah, and acceleration, we'll assume that's a y component as well. So we'll assume negligible air resistance. So as a vector, it'd be 0, -9.8 as a vector, the acceleration vector. By the way, that you can write vectors as either x, y, or x, y. Doesn't matter, except if you use matrices, it matters. Right. Okay, so the 1 second. Well, you know, you could use the kinematic formulas from your physics, but we're gonna just go to y coordinates and drop the subscript y for now. So you rearrange these infinitesimals, and so we're always going to get a constant of integration, and so our dv is going to turn into a v and a correction for the initial, which we could always write like that, right? This is the constant. It could go over the other side of the equation. It's a constant of integration, basically. So we we put an integral on both sides, and so we get an integral because v at t equals 0, it's got to match. These two things have got to match here, otherwise you made a mistake. And then it's minus 9.8 is the acceleration. And that's easy enough to integrate, right? You know, the integral of t to the 0 is just t to the 1 divided by 1. Plus your constant of integration, which is, just as I said, this thing here, vi. Okay, so it'll be negative 9.8 times t. And then, so the velocity at 1 second equals negative 9.8 times 1 plus the initial velocity, which is equal to 0. So it's negative 9.8. Oh, sorry, what am I doing? Oh my god. This is why I need more than 1 hour in these exams, man. It's like on autopilot. Oh yeah, no, that's right. There's no t. Yeah, no, that's correct. Add 1, divide by 1. Right, so yeah. Oh, I just had a brain meltdown there for a second. Plus 0. Yeah, so minus 9.81. Sorry, it's not 9.81, it's physics. Meters per second. Oh, sorry, damn it. What am I saying? They jumped up at 2.8. V is not 0, V is, so, yeah, so, okay, take a negative, subtract 0.8, we get 9, subtract 2, we get 7, so we negative 7.0 meters per second. Sorry. Forgot that VI was 2.8. Wow, that took way longer than it should have. My excuse is I'm actually a little bit tired from exercise here. My brain is going to sleep. Okay, I hit the water here, moving down. Find the maximum height above the water that I reach. Well, I prefer a sketch of this, right? I guess it's a velocity time graph, and the velocity slope is negative. Wow, so hang on. I'll shift that up quite a long way up there. 2.28, I guess, and then they head downwards to negative 22.68. Splat the water. Okay, this is the maximum height. Maximum height will be, you know, the y graph. It's going like a parabola like that. That's the cliff height there. Do we know the height of the cliff? Well, we better know the height of the cliff. What? Oh yeah, so we've got enough information, even though we don't know the height, because we know the final velocity. So we'll be able to work out what this time here is. T max. That's confusing because it's not the maximum height, it's the minimum height. let's just call it T2. So we've got minus 22.68 minus 2.8 equals minus 9.81 T2. So T2 equals I don't know, baby math, 19. Eight. 2.0285. 2.0286 actually. That should be enough when we round off at the end. We'll just keep four significant figures here perhaps. Although probably we only need to keep 2 significant figures because of the 2.8 and the 9.8. Anyway, why did we need to do that? Maybe we don't even need to do that. We need to know the height of the cliff really, don't we? It's kind of tempting to say that the maximum height would be between here and here, and this would be where the velocity is negative 2.8 meters per second here. It's kind of tempting to use that as a shortcut, right? And then we get a T1. So maybe I'll do that. I don't know. But in any case, we can check it later if we wanted to. So T1 is such that the V of T1 equals 0. So that implies 0 minus 2.8 equals negative 9.81 T1. So T1 is just 2.8 divided by 9.81. 9.8, sorry, 9.8. I'm not doing physics yet. 0.2857. Maybe keep an extra place. 28571. Now, seconds. Okay, so we've got velocity as a function of time equals minus 9.8 t plus 2.8, and the position, sorry, because this is what Vy, so the position that equals dy by dt. So the position will be so we can say dy equals v of the function of t dt, and then we can integrate both sides, putting in proper boundary conditions. Later, we'll do that in a second. So this will be equal to the derivative of the, sorry, the integral of velocity t here, which is minus 9.8 over 2. Okay, let's just do it. Plus a constant, which would be y at time 0, right? Call it y0. We don't know this. We don't know the position at the vertical height at time 0. You find the maximum height above the water the diver reached. So you sort of need some sort of initial condition here. Now, how are we going to do that? So we know, okay, well, I don't know, what's 9.8? 4.9, right? Now y0 is time naught, but we know y equals 0 at t2. We don't know what y is at t1. That's what we want to work out. So that implies at 0 equals negative 4.9 t squared plus 2.8 t. Sorry, I should put in the numbers here. T equals t2. That's 2.0286. Oh man, looks like it's going to be a calculator, severe calculator effort here, because there's no way we're going to factorize this by hand, right? 0.0286 plus y0. Okay. Oh, we don't need to factorize it. We just do a straight calculation. 4.9 2.0286 squared minus 2.8 times 2.0286. Calculator time. 4.9 2.0286 squared minus 2.8 times 2.0286. 14.5. This looks about right. .48 meters. That's where they start. That's how high the cliff is. Finding the height of the cliff above the water. Find the maximum height above the water. Anyway, so that means y as a function of time is minus 4.9 t squared plus 2.8 plus 14.484. Okay, therefore the maximum height will be y of t1. T1 was 0.28571 squared plus 2.8 0.28571 plus 14.484. Okay. I'm going to save a little bit of time here, but obviously it might take you longer in the exam, but I've waffled on and made mistakes, so I'm probably still at real exam time for myself, in which case I've probably already failed. What? Oh yeah, so I've got the signs around the wrong way because I was reusing the previous formula. That looks better. Should be higher than the 14.4. What is it? 14.8. So 14.9 meters to 3 significant figures. We don't want to make it 15 because that's a bit gross compared to the 14.4 here. So we'll keep our tens of centimeters here. Height. Oh, sorry. Maximum height. Let's call that y max. In that case, we don't have to tell the examiner that we've just solved it. That it's implicit that we solved it. Okay, quick cup of tea here. curve passes through a point, derivative is given. Find the coordinates of the point on the curve. Yeah. The coordinates of the point on the curve will be 2, comma, f of 2. Yeah. That's a fundamental theorem of calculus here. Yeah, so if we do an indefinite integral, we'll just add a constant on here, plus a constant. Okay, so integrating that, we get 6x cubed over 3 plus 5x squared over 2 minus x plus a constant. Alright, so that's 2x cubed plus, but we know a point on the curve, so we can find out what k is. So I don't know if you want to do it exact. 2.5 is 5 over 2, right? And put x equals 1 there. 1 cubed times 1 squared minus 1 plus k. So subtract 5 over 2 from both sides, and we get then we've got 2 plus 2 minus 1, so 0 equals 1 plus k. So that means k equals -1. So that means f of 2 will be equal to 2 times 2 cubed plus 5 over 2 times 2 squared plus k, which is -1, which is what that's, it's 8 times 2, that's 16, and then this is 5 times 2 is 10 minus 1, so it's 26 minus 1, which is 25. Therefore coordinates are 2, 25. Not going to bother. Not going to bother to double check that in any way. If you're doubting your anti-differentiation, just differentiate. So 6x squared, check. 5x, check. -1, check. Oh, so we want distance. Speed equals the derivative of distance with time, and since its speed is changing with time, it's not a constant, so we can't use the gross approximation of a difference function. It's got to be smooth calculus function, since v is not equal to constant, right? Okay, so that means it's an integral. So what you do is you do dx equals v dt. You just put the dt up on the right hand side, left hand side, and then to get rid of an infinitesimal, you integrate it. Okay, so it's the integral of v with respect to time, so it's plus 1 in whatever units we've got. Technically you're supposed to put brackets around it, but a lot of people don't bother with that. It's implied by the integral sign and the dt at the end. Other people would do dt first and then 0.3 t squared plus 1, but that's really ambiguous, because is the 1 in the integral sign or not under the integral sign? So in that case I would put a bracket around it. But if you put the dt on the right hand side, you don't. It's clear that you're integrating the whole thing here, so you don't really need the bracket, which is kind of nicer, I suppose. But anyway, we've got to integrate, so it's 0.3 t cubed over 3 then, plus. Now this is, remember, that's t to the 0. So when you integrate that, it's t to the 1 divided by 1. Plus some constant, call it x0. So 0.3 divided by 3 is just 0.1. And passing a sign straight down a footpath. Ah, yeah, so starts off at 1 meters per second, but let's say that at the sign x equals 0, right? So that's at t equals 0. So x equals 0 at t equals 0. So that implies 0 equals 0 cubed plus 0 plus, 0 cubed plus 0 plus x naught. So that means x0, x naught, the constant of integration, is just 0. That's not why I called it x naught. I could call it anything I like. Often it will be x at time 0, but I could just call it k for a constant, right? Integration constant. So that means the total function for the position is just given by that. And so after 3 seconds, the position of the sign is equal to the position is equal to 0.13 cubed plus 3, which is 0.1 times 9 plus 3, which is equal to, well, 0.1 times 9 is 0.9, so it's equal to 3.9 meters. How far is a scooter? Call this x of 3. So if you say what it is here, how far, you just don't have to write any more verbiage here. Oh yeah, so this is one of those tricky ones. Remember I said that going from f to f prime to f is the harder one. So we've got to draw a function whose gradient is this thing here. So here the gradient is 0. Slope of f equals 0 when the function itself is 0. So do we have any other information? We don't have any information. So when we do an integral, so this the f is the integral of f prime. So we could just assume a constant k equals 0 if we wanted to, and then we could plot the thing here. Anyway, here we get slope. It's approximately, okay, let's figure out the straight line from here to here. Oh god, it's hard to draw it. So it's roughly like that, right? So if we do it like this, we've got to go along one. It's hard to figure it out, and then go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. Slope approximately 6 here, plus or minus 6, because here it's negative. Oh, sorry, it's It's not the slope I want. I'm still doing it the wrong way around, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10. Slope of fx equals negative 10 at this point here. Right, and then 1, 2, 3, 4, 5, 6, 7, 8. So at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Slope is plus 8. So I'm going to sketch this in here. Minus 10. Negative 10. That's pretty steep. Slope is 0 here. Slope is 0 here. And then at 10, the slope is again 0. That's positive. So slope is positive all the way up here until we get to this point here, and the slope is 0 again. And then at this point here, the slope is back to negative 10. And the maximum slope is, this is the maximum slope here. Hang on, did I get it right? Let's shift it along here. And then forever on the left is negative. So a possible curve would be something really steep. So 10. So if we go 5 each side of this, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. Well, that won't be a slope of 10. 10 will be 10 over 2. So if we cut the interval by half, we draw a line like that, that's kind of the slope there. So it's pretty steep there, pretty steep like that. Now here 8 in between, so here was some, it was 0, and here in between it's plus 8, so that would be like if we go halfway and then 4 downwards, 1, 2, 3, 4, 1, 2, 3, 4, it'll be kind of from here to here. So it's sort of that kind of steep, roughly like that. And then minus 10 again, it's like so it'll be 1, 2, 3, 4, 5, go halfway along. 1, 2, 3, 4, 5, halfway along. So from there to there is sort of pretty steep like that. So it shoots up like that, comes down like this, and then it shoots up like that, and then 0 there, and when we hit this one, we've got to go negative 10 here, something like that. Again, check that slope is positive. Sorry. The slope is negative, and it's negative from here to here. So that should be about like that. And then the slope is positive, and then the slope is negative. That's a sketch. Of course, we could lift it up anywhere. We don't have to assume k equals 0. We could just, with up to an arbitrary vertical shift. Also, we don't know the values of these points here, I don't think, because we could shift it arbitrarily, right? So we don't really know the scale and arbitrary y scale. We could rescale the y-axis a little bit well, not arbitrary, because I'm using the I could scale the minimum maximum. I could move this up and down a little bit, but not too much, because I've got to respect these gradients that I've sort of computed. So slope approximately 8, and here the slope approximately -10, and here the slope approximately -10. Okay, wasted enough time on that one. All right. Alright, then A and B are on the parabola. Also C looks like it's on the parabola. Find the height of the wall AF or BE. By symmetry they're the same. Oh, okay. Implies the house max area. Okay. Now C, I'm going to assume, is also on the parabola. Yeah. Okay, so the area is the integral. Wow. So the area of the parabola area, the total area from here to here, above the axis, is going to be oh yeah, so we can work out those points here. So that's equal to 3. There's a difference of 2 squares, so it's 3 minus x, 3 plus x. So you remember the difference of 2 squares formula. If you have a minus b all squared is equal to a plus b, a minus b. That's just a common formula. You can work it out when you expand it, right? And this is the difference of 2 squares, 3 squared and x squared. So take the square root of each of them. Sorry, I got that wrong, didn't I? I was like completing the square. A squared minus b squared in brackets, like that. 2 squared numbers. All right, that means this point here is going to be -3 is 1 root. And this point here is going to be +3. Yeah. Oh yeah. So the house shape could be either one of these, right? Ah, so wait a minute. We don't want to maximize the parabola because the parabola is fixed. So we want to maximize just that rectangle shape here. So and which means we can maximize half of the shape here if you like. So the area is equal to so I don't know. Let's just do it as 2 blocks, right? That plus the roof. Right. So and let BE equal AF equal the height of the wall. Let's call it W. So there's a W here, and then this height here is C minus W. Let's call that C minus W. So it's going to be an EF equals the base. Let's call it B. So W times B is the rectangular area here, and the triangular area would be half the base times the height, which is C minus W. Now, what's the coordinate of C? It's when the parabola when x equals 0, so C is equal to 9. So it's WB plus a half B times 9 minus W. And so I want to try and eliminate either B or W and then do a derivative. So this is currently a function of W and B. Okay, and we want to eliminate that. So so what I've said is B is F E to F. So the coordinate for E is going to be negative B over 2, and coordinate for F is going to be plus B over 2, right? So if we plug B over 2 into the this is the area. So the point A coordinates AX comma AY, the X coordinate is going to be equal to B over 2, and the Y coordinate will be the value of the parabola when X is B over 2. So it'll be 9 minus B squared over 4. Okay. What did I call W? The wall. W is the wall. Okay, but that is the value of W here. So that implies the wall height equals wall equals W is 9 minus B squared over 4, and that is true no matter what shape a house. If it's the roof is really tall, or the base is really fat, skinny house, tall house, fat house, short house, which means we can use that in here to eliminate W and call it just a function of B now. B is, remember, is the total width. Right. So it's W 9 minus B squared over 4. This is going to be a bit of math here. Half B 9 minus W. Okay, so 9 minus 9 is going to cancel. And so just tidying up this a little bit, it's 9B minus B cubed over 4 plus, sorry, it's going to be negative because this cancels this. And then it's negative, so it's positive. B cubed over 8, right? Well, those are both B cubed, and negative a quarter plus 8. That's 2 over 2. That's 1 minus 2 over 8. That's a negative 1 over 8, right? 9. Oh, let's keep it as a polynomial since we're going to have to differentiate it, I guess. Let's not factorize it. We could take one of the b's out, but so I think that's negative b cubed over 8, and therefore the rate of change of area as we imagine varying the base height will be 9. minus 3b squared over 8. Okay, so this is a cubic, but it's a negative 8 cubic, so it actually, instead of going like this, it's going to go something like this. And we're going to imagine that okay, so, but in fact, because there's no constant term here, right, it hits the y-axis. Oh, hang on. Yeah, hang on. The y, the intercept, if we plot it, the area like this, with the base varying the base, varying the base on our drawing plans, the y-intercept is 0 here, plus 0 here, right? And so if it's a cubic, it's going to kind of possibly go down and like that, or it's going to go well, actually there's two roots, right? So it's b times 9 minus 1/8 b squared, right? And so one of the roots is that. The other root is going to be b squared equals 0, or b squared equals 9 times 8 is 72, right? So b is going to be plus or minus the square root of 72. Hope I'm not rushing this too much. Around about 8.4, plus or minus 8.4. So if we go plus 8, then it's got to go like this, right? Around about 8.4 here. So the part that we're interested in looks a little bit like a so positive b is what we're interested in, and positive area. So this is the only part that we're interested in. So it looks kind of like a concave parabola, even though it's a cubic. And so this will be the maximum area. And we're going to guess it's around about b is approximately 4, maybe 4.2 or something like that. Now, cubic polynomials are not symmetric, so the left hand side is not the same as the right hand side here inside this dome. So we're going to have to do the actual calculation to figure it out. Okay. So area is the maximum when the derivative is 0, the slope is 0. This is the slope. So it'll be 9 minus 3 over 8 b squared. Therefore, b squared equals, the other solution will be this negative area here. Drop the 9 on the other side, it's a negative, but then multiply by negative 8 over 3, it's positive. 9 divided by 3 is, sorry, a bit messy here. Uh, 3 times 8 is 24. So b is plus or minus the square root of 24, which is a bit less than 5, which is just what we wanted. 4.899 approximately. That's equals the square root of 24. Approximately. Okay. So obviously it's plus 4.89. 4.9 meters to two significant figures. Do we have to find the actual area? Well, I've already justified. If you find a height of the wall, could have called it h, of course. 9 minus b squared over 4. Now b squared was 24 exactly, but 24 divided by 4. Oh, so, yeah, sorry. 9 minus 6. 3 meters. Did it say exactly? Find the height of the wall exactly. Yeah, we could find it exactly. Sip a cup of tea. Okay, now we've got freedom for the height. Oh, this is a pain. I mean, obviously at the end of the exam they're going to give you, well, it's the last one, so let's just dig into this. So it's kind of the same as before, right? Let's just make a note. Let's say BE, which is AF, equals the wall height W, right? So it's W. And let's say the base height, let's say EF equals the B base height. So this is negative B over 2, and this is B over 2, same as before. Unfortunately, we're going to repeat a lot of it. So if x component is equal to B over 2, and so this is C is equal to D, x component of, sorry, y, y, C x y is going to be 0 comma D, right? And a y component will be the value of the parabola at f, which is b over 2. So that's going to be d minus whatever k is times b squared over 4, right? Okay. So those are some definitions. So this triangle height here, so the height of the triangle, C to A, that's going to be D minus W, right? Oh, okay, so this is W. Well, maybe I should just brute force this thing. So area of the house is going to be actually I was wrong above here. This was like half the area of the house. Okay, so we're going to have to justify this. By symmetry, maximum of half times the area will give the same W and B as maximum of the whole area, right? So we can do half the area here, half the area max, the area over 2, right? I think that's everywhere. Corrected everything there. This is kind of the area over 2, half the area over 2, right? So again, half the area of the house is just going to be, or this time I could do the whole area of the house if I like. Why not? Why not? Then I don't have messy halves. It's 2 times the triangle plus the half rectangle, right? Which is equal to 2. Now the triangle is a half the base times height, and the base is b over 2, and the height is d minus w, d minus w. And then the rectangular area is w times b over 2, right? Okay, so we get rid of the halves here, and we just get b over 2 d minus w, and we worked out the w from the formula for a. It was kb squared over 4. K and d are going to be unknowns, right? 2 brackets there, and the 2 cancels on the last term, so it's just w times b, which is b times w. Okay. Now we've sort of solved it really. I guess the negative signs are a bit annoying, but yeah, I don't know. A B E F. This is going to be W times B, which is same as this thing here. Okay, that equals W times B, which is equal to area of A, B, E, F. Already worked it out. And the area of the triangle would be half the base. Oh, sorry, so ABC. Well, the base of the triangle overall is B, so again it's a half the base, which is B times the height, which is C D minus W, which is this thing that we had before here. So this is the area of ABC. No need to repeat it, and the D's cancel here, so we get K B squared over 4, which is K B cubed over 8. Okay. And we get maximum area of the house when dA house by dB equals 0, which implies dA ABC plus area of ABEF by dB equals 0. Which implies when you differentiate two functions, f plus g is the same as the derivative of the two functions separated by a plus. In other words, the derivative is called a linear operator. Okay, so this is just going to be ABC by dB plus the derivative of ABEF respect to B equals 0. When the area of the rectangular sections, so when A BC is max, then the derivative of its area will be max, will be 0, and when the area of ABEF is a maximum, then the derivative of APEF is going to be 0, which implies the derivative of the area of the house will be equal to 0. Because these two things here will be equal to 0. Which implies the area of the house is the max. That's really all we have to do. We don't have to actually do the differentiation to show it. We just have to use basically, we're using this result here for the derivatives. Derivative of sum is the sum of the derivatives, is how you say it. Okay, we could say quo erat demonstratum QED, which is what we wanted to prove. Desired to prove. Quo erat demonstratum is probably not what we desired to prove, it just is what we wanted to prove or what we wanted to show. Demonstratum is to show, quo erat is something like which is what. And that's all we need to do. Alright, we finished that. Check the time, way over time. How sad. That is the demo for 2019 Calculus Level 2.